This screencast is Chapter 4, Part 9, and we are going to be looking at some different types of equations and rewriting them. So in 132, you now have a lot of experience working with equations that compare two quantities. For example, while working on linear equations, which is our lines, you found the form y equals mx plus b. So if we were given the equation y equals 3x plus 4, where does the graph cross the y-axis? Hopefully, you're going to say at 4. So 0, 4. That is that starting value. That's the y-intercept. How can you tell from the equation? Well, that is the b. So b is equal to the y-intercept. So what is the rate of change for the line? That is going to be our slope, which is our m. So that's going to be our 3. Moving down to 133, you can find the slope and starting value for y equals 3x plus 4 quickly because it is in that y equals mx plus b format. So it's easy to identify. But what if the equation is in different form, such as standard form? So standard form is when we have our x and our y together on one side of the equal sign. So can you easily tell what the slope of the line is? So by looking at it, typically we're going to say no. So we are also going to try to find out its starting value. So what we're going to do is we are going to, in part C, solve for y. So we want to get this y by itself. So we are going to start by adding 6x to both sides. So we have 2y is now equal to 6x plus 10, or 10 plus 6x. And then we're going to divide every single part by 2. So y is going to equal 3x, because 6 divided by 2 is 3, plus 10 divided by 2, which is 5. And now we can easily identify the slope and the y-intercept. So our slope is going to be our 3, and our y-intercept is going to be 0, 5. So 134, many times in real-world situations, a formula with more than one variable may not be in the form you need. So what we're going to do for these problems is we are going to rearrange them so that we can solve for the variable that's being asked about. So in letter A, we are given that W equals F times D. So F is going to be the force, and we want to find the force needed to move a piano given the amount of work applied, which is W, and the distance moved, which is D. So this equation is work equals force times distance. So that's what our variables stand for. So we want to get the capital F alone. So we are focusing on that. So if we look to see, what's going on, well, we're multiplying the force times the distance. So the opposite of multiplying by distance would be to divide both sides by distance. So our force is going to equal our work divided by the distance to move the piano. In part B, we are given that Fahrenheit is equal to 9 times Celsius divided by 5 plus 32. We want to find the temperature in Celsius C when given the temperature in degrees F. So we are going to solve for C. We want to get C by itself. So we are going to start by subtracting 32 on both sides. So F minus 32 is equal to 9C over 5. So from here, because we have this 9C divided by 5, I'm going to make this a proportion. So I'm going to put F minus 32 over 1, and we are going to cross multiply. So we talked about cross multiplication earlier this unit. So 1 times 9C is 9C, and then 5 times our Fahrenheit minus 32. So 9C is equal to 5F minus 160. So we're distributing that 5 inside the parentheses. Well, C is still not by itself, so we're going to divide everything by 9. So our Celsius is going to equal 5 times our Fahrenheit divided by 9 minus 160 divided by 9. So we are solving for Celsius. In letter C, we have the Greek letter, which is rho, looks like a P, and that is equal to our mass M divided by our volume. So we want to find the mass of the precious stone. So we are going to solve for the M. So we have our Greek symbol rho, which is the P, equals M over V. So we want to get the M by itself. So similar to what I did in the last problem, I'm going to make this a proportion, and now we can cross multiply. So rho times V would be the rho V equals 1 times M, which is M, and now M is by itself, and that is that.